You had some of these on the handout where you were trying to find the missing angle. So I'm telling you, find the value of s in the interval 0 to pi over 2. If you are between 0 and pi over 2, what does that mean? What quadrant is that? That's quadrant 1. If cosine is equal to 0.9685, do we know when cosine is 0.9685? No. So we have to use our calculator. All right, if I'm going from 0 to pi over 2, is pi over 2 degrees or radians? Radians. So you need to make sure your calculator is in radian mode to start this. So that interval kind of told me two things. It told me that I was in the first quadrant, and it also told me that I need to answer in radians. All right, if I am looking for the angle, how do we type this in? To move that cosine the other side, it becomes an inverse. So you are going to do second cosine, 0.9685. And I get approximately 0.2517. That doesn't have a pi in it, but that's okay. Your calculator, we will talk more about this in chapter 6 about getting our answers in the right quadrant. When you type this in your calculator, it will give you the answer in quadrant 1. So we don't have to worry about that. Any questions there? Okay. Let's look at this one. If I am between pi and 3 pi over 2, what quadrant is that? Quadrant 3. Okay, do we know when tangent is 1? Yes. So we don't need our calculator here. We're going to do this by hand. And I'll know if you use your calculator for this because you're going to get a decimal when we will have an answer with pi's. So I'm going to find my reference angle. When is tangent 1? When x and y are the same. So if you think about your circle, that point where x and y are the same, that's 45 degrees, which is pi over 4, because we're in radians. So now if I want pi over 4 in quadrant 3, what do? Add 1 to the numerator, right? In quadrant 3, the numerator is 1 bigger. So our answer is 5 pi over 4. Any questions on this? Let's look at a nice, pretty problem. You probably don't want to copy this whole thing down in your notes, but let's go through and pick out what's important. So the angle of elevation, theta, of the sun in the sky at any latitude L is calculated with this formula. So our formula is probably important. If you're jotting something down, I would write that formula down. It has lots of sines and cosines and different variables in it. So sine of theta is equal cosine of d times the cosine of L times cosine of omega plus sine of d times sine of L. It tells us theta equals 0 corresponds to sunrise. And so when it's directly overhead, that would be when our theta is pi over 2. Omega is the number of radians that the Earth has rotated since noon. D is the declination of the sun, which will vary because Earth is tilted, okay? My actual example is on this next slide. So Sacramento, California has a latitude L of 38.5 degrees, or 0.6720 radians. Find the angle of elevation theta of the sun at 3 p.m. on February 29, 2012, where at that time the D was approximately 0.1425 and omega was 0.7854. So we have this formula that we wrote down. All right. My whole goal is to find theta, so I don't know that. But I do know all these other values. My D is 0.1425. L was what? Right. I gave you degrees and radians. You have to use the radians, so 0.6720. Omega 0.7854. So this problem looks pretty scary, but ultimately, what are you doing? Plugging it all in your calculator. You have to be careful each time you open or you push a trig function, it opens a parenthesis, so make sure you're closing it. And I'm just going to type in the entire right-hand side. So I get sine theta to be 0.63617. How do we find theta? Sine inverse. We are in radian mode, so the answer we get out is a radian measure, not a degree. And I get my theta to be 0.6895. Any questions there? I want to actually look at a problem in the book next. I want you to turn to page 118, look at number 53. Take a second and see if you can figure that one out. Alright. And if you read the directions, it shows an angle in standard position whose terminal side is intersecting the unit circle. On the unit circle we talked about yesterday, it's a circle of radius 1. The x value of every ordered pair on the unit circle represents what? Cosine. The y value represents sine. So if you look on 53, it gave you an ordered pair. 5/13, -12/13. So, what is sine? yi. Cosine then is 5/13. How do you get tangent from this? Sine over cosine, or y over x, so negative 12/13 divided by 5/13. Flip and multiply the 13s, cancel, and we get negative 12/5. Cosecant is what? And 13 over 12, it's just a reciprocal of sine. Secant would be 13 over 5, the reciprocal of cosine. And cotangent would be negative 5/12, the reciprocal of tangent. So I told you yesterday, we didn't learn every single point on the unit circle. We just took the common ones. But if I gave you a picture, you can get every trig function from that order pair on your unit circle. Right. Questions there? We're going to switch gears for a second. I want you to get out your Chromebooks, please. Okay, so this will be the final section in Chapter 3. And it is actually very similar to Section 3.2, where we were finding like arc length and area. We had those formulas we were using. This section we are finding a couple other things, so I have a few more formulas. All of these formulas are on the formula sheet that I give you, so you just have to be able to use it. You need to know what your variables stand for and be able to work through them. The first formula, we are talking about linear velocity. So all of these are dealing with circles. Oh, that's a bad circle. So you have some point on a circle. Radius is r. And we have point P moving outside on the circle. And we know that the distance on the outside of the circle is arc length, so that is our S. Okay. If you know how long it takes that point to move that distance, you can find its speed, its velocity. So linear velocity, V is linear velocity, it's like our linear speed. It's S over T, arc length divided by time. In other words, it's the distance you travel divided by how long it took you to do that. The biggest problem that people usually have in this section is we're talking about two types of velocities, a linear and an angular, and they use the wrong formula. A linear velocity, it's a linear distance, so it'll be something like miles per hour, inches per second, meters per minute, those types of things. A linear distance is something that you could measure with a ruler divided by some unit of time. The second one is talking about angular velocity. So it's the same scenario that we have a point on a circle, with some radius r. But this time, instead of talking about how far the point moves on the outside of the circle, we look at the angle that it has passed through. And so if you take that angle divided by time, you get omega. It's called angular velocity. So it's just your angle divided by time. So we're either talking about how fast the point moves outside the circle or how fast the angle is changing. For this to work, what do you think has to be true about theta? Has to be in radians, just like everything else we've done. That will also be true about omega. It has to be radians per minute or radians per second. If I gave you like degrees per second or revolutions per hour or something like that, we would have to change our units first. So on this, both omega and theta have to be in radians for the formula to work. Okay. The next thing that I wanted to talk about is how these two formulas are related to one another. Okay. So let's go back to the formula we have before. S equals R theta. What do those represent? S is what? S is arc length, R is radius, and we know theta is our angle. Okay, so we can use that to connect the two formulas. We know the formula we wrote down for linear velocity is V equals S over T. But if S is R theta, we could say that means RV is R theta over T. But what's theta over T? That's our omega. So the third formula just connects the two. It's V equals R omega. The next slide, I just gave you a box with these formulas. We're really not going to use this middle piece, that's just how we got there, but the three variations that I use, the ones that I put on the formula sheet, are those three main ones. How to find linear velocity, angular velocity, and going back and forth between the two. So, I'm done, finally, for today. I'm going to give you your book assignment right now so you can get that written down tomorrow. Remember, first thing, 10-question quiz without a calculator. Then, if you don't have your handout done, you finish that. Then you work on the book problems. Handout and book problems are due on Monday. And bring this notes handout and we'll pick up with this section then. So there is your assignment.